This is the LRC circuit using an AC input. For this lab, we will be using the old oscilloscope and the function generator. In order to give the oscilloscope and the function generator a separate ground, on the function generator we use the 3 to 2 prong adapter. On the one setup where we want them to have the same ground, we'll do that with a wire between them. We will be using banana cables, so we need to use the BNC to binding post adapter. Put it on channel A and channel B. Make sure that the connection is secure so you get a good signal. And also put it on the output of the function generator. We will use a decade resistor box and a decade inductor box and a decade capacitor box. We are going to set up the following circuit. We want to measure the potential difference across the function generator and the potential difference across the resistor. Both measurements will be made relative to the point A. First, we will connect the black post of the function generator to the right side of the resistor. Connecting the black post of the function generator to the right side of the resistor. Then we will connect the left side of the resistor to the right side of the inductor. The left side of the resistor is the middle post on the box, and then I plug into the right side of the inductor. Now we connect the left side of the inductor to the right side of the capacitor. Here I am connecting the left side of the inductor to the right side of the capacitor. To complete the circuit, we connect the left side of the capacitor to the red post on the function generator. Here I am connecting the left side of the capacitor to the red post on the function generator. Now we need to attach the oscilloscope for taking measurements. In this first circuit, the function generator and the oscilloscope have the same ground. So we will attach a wire between the black post of the function generator to one of the black posts on the oscilloscope. So here I attach a cable to the black post on the function generator. I can attach it to either of the black posts or to the ground on the oscilloscope. I wish to measure the voltage across the function generator. In other words, I want to measure from A to E. So I connect the left side of the capacitor, which is the same as the red post on the function generator, to channel A, red post of the oscilloscope. So here I'm connecting the red post of the function generator to the red post on channel A. We wish to measure the voltage across the resistor. We want to measure from point A to point B. So we attach a cable from the left side of the resistor to the red post on channel B of the oscilloscope. I attach to the left side of the resistor, which is the middle post of the box, and I put it in the red post on channel B. Our circuit is now ready to take measurements. We will be using 100 ohms on the resistor, 90 millihenries on the inductor, and 1 microfarad on the capacitor. Set the oscilloscope on channel A. Set the trigger to internal and turn on the oscilloscope. Turn on the function generator. If you don't get a signal, you might try adjusting the trigger knob. You can adjust the position, but we want it in the top half because we're going to put the other one in the bottom half. Also adjust the volts per division or the output on the function generator so it takes up less than half the screen. To display the other channel, we want to move the switch to dual. Make sure that all of the red knobs are turned fully clockwise. The function generator should be set around what you calculated in the lab for the natural frequency. It should be displaying a sine wave, of course, and all of these buttons should be out. We need to make sure that channel B is not inverted. We're going to invert it later, but for this circuit we want to push this button in if it's not already in, and then adjust so that channel B is farther down the screen. Play around with the adjustment of the frequency on the function generator and watch how the phase difference between the two signals changes. To properly measure the phase shift, we want to trigger both signals off of the same source. So switch the trigger to channel B and adjust the other dials and knobs up in the trigger area to get a stable signal. At some frequency other than the natural frequency, we see that the peaks of the waves are no longer aligned. The waves are not in phase. We wish to measure the time difference between these two waves. These waves are oscillating back and forth relative to some ground. Switch the switch here to GND or ground. We're going to do the same on the other side too. You will notice that the signal goes away because it's not being triggered anymore, so just switch it to line. Now we want to adjust these ground levels to some convenient measuring line, so do that for both of the waves. Switch the signals back to DC and put the trigger back on channel B. You may have to adjust the trigger source a little bit to get it. One of the best places to measure is where the signal crosses the ground. Like here on the top wave and here on the bottom wave. These don't need to be on the same setting, so adjust them for easy measurement. We want to adjust the time per division to stretch the signal out as far as possible and still manage to get both signals crossing their ground line, either on the way up or both on the way down. You can adjust the trigger so that the edge of the graph touches the ground line. You can also do the horizontal adjust to make that happen. So I'm stretching it out. I could readjust the trigger a little bit too if I want to, just to kind of get the wave so that I have one of them crossing the ground line and the other crossing the ground line sometimes later. And then as far as I can stretch the signal out and still have them both cross the ground line, adjusting the trigger a little bit here or there helps. Till I've stretched it out as far as possible. Then we want to count the number of divisions between where one of them crosses the ground line and where the other crosses the ground line. Multiply the number of divisions times the time per division on the horizontal sweep, and that'll give you the time between the two waves. Your lab will explain how to turn the time difference into a phase difference.